All right, let's take a look at this next section. This starts chapter 4. We don't cover all of chapter 4. Starts off with a fairly quick but in-depth review of the quadratics that you learned in Math 1010. Quadratics are very important. Their behavior and the way they operate are really important. So we need to make sure that we understand these, along with reviewing some really important skills. So let's take a look here. This says if we need to graph a linear equation, we normally put it into this form right here. So this is slope-intercept form, and it's a really graph-friendly form because you can look at it and you can say, oh, it crosses at this point on the y-axis. It has this slope, and then you can just do up and over, down and over, whatever it happens to be, and you've got your line. Okay. The same thing is true when we want to graph a quadratic equation, or in other words, we want to graph, what shape is this if we were graphing a quadratic? Quadratic? What's it called again? It's called a parabola. Okay, so if we're going to graph a parabola, we want to put it in a graph-friendly form. It looks like this. Okay, so we've got our function notation, f of x equals a, and then parentheses, x minus h, that quantity squared plus k. That's called, nope, vertex form. Because you can look at it and you can tell what the vertex is. It's got all those transformations just sitting right there for us, so we can tell that we've moved it opposite of this number, opposite of h. That's going to be the x-coordinate. Same as k, that's going to be the y-coordinate of the vertex. And then the sign of a will tell us whether it opens up or down, and the number will tell us whether it's been stretched or shrunk. Shrunk if it's a number between 0 and 1, stretched if it's a number that's bigger than 1. Okay? The problem is most quadratics don't come like that. If they did, it would be pretty easy. We could just stick with the stuff that we know in 1010. Okay, but most of the time they come in something called standard form. It looks like this. It's an expanded quadratic. We've got a squared term, a linear term, and then a constant at the end. I'll say that again. Squared term or a quadratic term, a linear term, and then a constant at the end. They don't all have to be present. We could just have the squared term, and then it would be a really easy quadratic because it would be centered. A vertex would be at the origin. Okay, if it looks like this, then in order to make it look like this graph-friendly form right here, we have to complete the square, and hopefully you remember this from 1010. This is a copy of what you were shown in 1010. If you were shown something else and you stuck with that, that's fine, but I would caution you, it's really important that you do that middle term the right way. Take half of the middle coefficient. Don't always say, I'm just going to divide it by 2. That can get more complicated depending on how ugly the function is. So let's take this one right here, and it says, write the quadratic in vertex form and then graph the function. So in order to do that, we're going to take it and we're going to go like this. Now, I can't really mess with the f of x. So all the changes, and this is important, all the changes that I make to this have to be done on the same side. So the first thing I'm going to do, and I'm going to do one extra step on this one that I don't normally do. Okay, I'm going to do 2x squared plus 8x. I'm going to make room to complete the square. So I'm going to put a number right there that's going to complete this square. But you'll remember we can't complete the square unless this number, the leading coefficient, the coefficient of the squared term, it has to be a 1. Okay? Yeah. Divide this side by 2 and make that not 0. It would make it a 1. That does a couple of things. It makes this a 4. It makes this a 5/2, so it makes that a fraction. And you can't just divide this side by 2 without dividing the other side by 2. And we really don't want an f of x over 2. Does that make sense? We're going to take it out. Good? Okay, now, usually I'm going to skip to this next step right here. So I'm going to write f of x, and then I'm going to take out the 2, x squared. This is a 4x. Again, I'm going to leave room to complete the square, and then I'm going to put plus 5. So you'll notice that everything that I've written here in blue, and you can barely tell that that color is blue up on the screen there, but everything that I've written there in blue was in the problem to begin with. All I've done is just move things around just a little bit. If I multiply through, there's 2x squared. If I multiply through, there's an 8x, and of course the 5 sitting on the end. Any questions there? Okay, now, this is where we're on step number 3 here. We take half the middle coefficient. So half that middle coefficient is a positive 2. So I'm going to write a positive 2. I encourage you to put a little circle around that, a little dotted circle, because we're going to use that again. Then I'm going to take that number and I'm going to square it. So if I square that, that's a 4. Now, if you were in my class, I said when you do this, you should immediately draw this line right here. We're going to draw an arc from what that number is out front to that right there. What that allows us to do is it allows us to figure out, you know what? I added 4 inside parentheses, but there's a number outside. By adding 4 inside the parentheses, what did I really do to this side? We really added 8. I'm going to put plus 8 up here, and then I'm going to write the exact opposite of whatever that number is right here. So what we've done here is this plus 8 gets canceled out by the minus 8. So the net effect of this is I've changed the way this looks, but I haven't changed the value of anything. I haven't changed the shape of the function at all. Does that make sense? Are there any questions to hear? Because from here on out, it should be pretty easy. It's stuff we learned in the last chapter and everything that we learned in 10-10. Good? Okay, so I'm going to come back. I'm going to start writing in blue again. So notice I haven't changed this side. It's still f of x. This side is now a perfect square of that variable, x, and that number that I had circled right there. That's why I circle it, because we're going to use it again. And then I put the two of these together, and I get a minus 3. This is now in vertex form. And the vertex is -2, comma, -3, opens, which way does it open? Opens up, because that's a positive 2, and I'm going to write vertically stretched. So vertical stretch there. So now we'll go ahead and graph this. So the vertex is at -2, -3, so we're right here. It opens up, so we're looking for a parabola that looks something like this. And it's been vertically stretched. So I'd normally go over 1 and up 1. I'm going to go over 1 and up 2. Same thing on the other side. I normally go over 2 and up 2 squared, so up 4. I'm going to go up twice as far as that. So I'm going to go up 8, and that's going to put me right here. And then same thing over here. And the reason I know this is the same thing over here is because I have an axis of symmetry. So if the vertex is at -2, -3, what's the axis of symmetry? X equals -2. Okay, and I've got these points right here. I've got these 5 key points on the parabola. If you graph this much, nobody's going to question whether or not you know what you're doing. You clearly know what you're doing. This one right here would be -1, -1. This one is 0, 5. This one right here would have the same y coordinate. So this is going to be 5. This is going to be -1. And this one's going to be -3, and that's going to be -4. Okay. Any questions there? Does this work if you plug it in? You plug in a 0, that's 2. 2 squared is 4, times 2 is 8. 8 minus 3 is 5. This happens to be the y-intercept. Okay, got a little bit lucky on that one. Okay, any questions there? It's all 10-10 stuff, right? All right, so if we have something if we have a quadratic in vertex form, the vertex would be at h, comma, k. The axis of symmetry is always x equals the x coordinate of the vertex, so that's going to be x equals h. The graph will open up if a is positive. Mathematically, we'd say it like this. If a is greater than 0, it'll open down if a is negative. I like that description, but technically that would be when a is negative. Okay? If it opens up, it will have a... Seems a little bit weird, a little counterintuitive, but if it opens up, it has a bottom. Okay, so it has a minimum. And if it opens down, then it'll have a maximum. Parts of the graph that go up, this was not covered. Very good. Parts of the graph that go up from left to right, we call that increasing. And the parts of the graph that go down, we call that decreasing. That was not something covered in 1010. We started figuring that stuff out in 1050. in chapter 3 about the behavior of a graph. Okay? Any questions? Yeah.
So, wouldn't the vertex and the x-intercept be opposite h? Because if you look at h, it says x minus a number, so take the other one, x minus x plus 2 is what it was. It's actually negative 2.
Right. So that's why this negative is in there to begin with. If we wrote this formula as x plus h quantity squared, then I'd have to have a negative h here and a negative h there. So by having the negative there, by saying it's the opposite of h, okay, I mean, we kind of account for the opposite by putting it in the formula. That's why it looks that way. It also has to deal with the fact that, remember we said if you make changes with the x inside parentheses before the function makes the shape, it does the opposite. That's why we account for it that way. That way we can just look at it and say, oh, that's h. So if it had been x minus 2 quantity squared, h would be 2. You can look at it and tell exactly what it is. Okay? I mean, you got to deal with it somehow. This is the way they chose to deal with it as a standard practice. Any questions? Okay, let's take a look at the next couple of problems. It says we also need to find the x and the y-intercepts. And remember to find intercepts, we make a little xy table, plug in a 0 for x and a 0 for y. Now, it's a little bit wordy, but that in effect is what we do to find those. Notice there will be always a y-intercept, but different possibilities for the x-intercepts. So we're going to graph a parabola that opens up. All right, that doesn't really look like a parabola, but you'll notice that we have an x-intercept here and here, and then I have a y-intercept right here. Doesn't really look like a parabola, but take my word for it. On this particular one, we have an x-intercept, only one. It comes down and touches the x-axis. So the vertex is on the x-axis. That's the only x-intercept that it has. And it has a y-intercept right here. Now, if I did one that looks something like this, it still has a y-intercept, but no x-intercepts. Okay? Now, do you remember how you can use the quadratic formula to find the x-intercepts? Okay, it does have something to do with that. We'll talk about that in just a second. So the quadratic formula, go ahead and write it down. You absolutely have to have this memorized. So if you can't write it down right now and be 100% sure that what you're writing down is accurate, I'm going to write it down in just a second. You make sure you lock that away. If you want to sing the Pop Goes to the Weasel song or whatever it is, I don't care how you get it memorized. Elaine, you'll sing it for us, won't you? Okay. So it's x equals opposite of b, or negative b if you want to call it that. And then it's b squared minus 4ac, and then all over 2a. Especially if you were in my class, where do people typically make mistakes with this? The minus 4ac part, the stuff underneath the radical, is where they typically make mistakes. And does anybody remember what that stuff underneath the radical is called? It's called the discriminant. Because it allows us to discriminate or discern between different types of roots, x-intercepts, solutions, zeros, whatever you want to call them. Okay. Does anybody remember what type of discriminant you have if the parabola has a vertex up here and opens up so it never has any x-intercepts? Yeah. It has imaginary solutions, so that means the discriminant is negative. So b squared minus 4ac is negative. Somebody remember what it is here? It's 0. Okay. And what is it if you have two x-intercepts? Normal. Okay. I'm going to put equals normal. Okay. It's positive. Okay. It's positive. Now, there's a special case here. If you have, if it's positive and it's a perfect square, then we get what we call rational zeros or rational solutions. Okay. So just keep that in mind. We did talk about this in 1010. That might come in handy down the road. Any questions? Okay, now, it's not like well, almost everything that we're going to talk about in this section you did learn how to do in 1010, but you're going to have to do a lot of stuff on the same type of problem in addition to a couple little tweaks. So let's take a look at this example right here. I've got several examples on the back side. The first one is this one right here. It's a little bit of a unique situation. It says we're going to graph that function right there. We're going to determine whether it opens up or down, and we're going to find the vertex, the axis of symmetry, the y-intercepts, and the x-intercepts, if there are any of those. And then we're going to figure out the domain and the range, and we're going to determine where the graph. Notice it says where. Where is a question about what the x-coordinates are. So that's going to be an interval where it's increasing and where it's decreasing. Now, I'm going to go through and do the problem this way. There are lots of different ways to approach this. This is the way I'm going to approach this particular one. So I'm going to put this in vertex form, a nice graph-friendly form. So I'm going to do this. So this is f of x. Notice there's no, the coefficient is already 1, so I'm just going to start my set of parentheses. Close the set of parentheses and then put the 9 there. I'm not going to do all of them this way, but I'd like you to do these the same way I'm going to show you here. Half the middle, yeah. You could if you notice that, okay? I want to do a little bit of practice completing this square, though, okay? All right. We'll point that out in just a second. I'll have you point that out in just a second, okay? Half this term is -3. Square it. That's going to be a 9. The minute you put this here, please draw this line so you don't forget this. The number out in front is a 1. So by adding 9 inside parentheses, I really did add 9. So it's a little bit silly to do that on this problem, but it's an excellent habit to be in, because what people generally forget is they'll put a 9 here and they'll automatically put some number over here. Okay? It needs to be the opposite of this number right here. It needs to be a -9. Now, what this goes to show is on this particular problem, look what we get. Perfect square of that variable, x, and that number, so -3, quantity squared. And what do we get out here? We get a 0. Okay? Now, I'm going to write the 0 on this particular one. And then Tylen's going to make the point that if you just look at this, isn't that a perfect square? It is a perfect square. It's a perfect square of x and -3, quantity squared. Happens to work out to be the same as we did right here. How often do you think that happens? Not very often, okay? So that's why I wanted to practice using this technique. Are there any questions to write here? Not very often, and I wouldn't bank on one being on the test, okay? Because usually we want to see if you can do this process. That completing the square is an important thing to be able to do. Any questions? Okay, once I get it to here, vertex 3, 0 opens up. Stretched or shrunk? Nope, nothing, just that standard old shape. So we're going to move this 3 units over here. Over 1 and up 1, back 1 and up 1, over 2 and up 4, back 2 and up 4. So the graph looks something like this. Okay, now I'm going to stop right there. I'm not done. We found the vertex, axis of symmetry, x equals 3. Remember, it's the same as the x-coordinate of the vertex, so that would be x equals 3. Y-intercept. Now, the reason I'm holding off on graphing the rest of this is I do want to figure out what the y-intercept is. Now, from 1010, somebody remember an easy way to find the y-intercept on this particular one? Thailand? Okay. There are a couple ways to do it. Because this is such a nice problem, I could go over 3. How far up am I going to go? I'm going to go up 9. Okay, in general, how do we find y-intercepts? Plug a 0 in for x. Now, you can do that in 2 places. If you plug it in here, you get -3, square that, you get 9. Or the easiest place to plug it in would be right here. In fact, one of the easiest things to spot if it's in general form or standard form like it is right now is the y-intercept. whatever the number is on the end, that plain old constant term, that is the y-intercept. So we could have, I mean, if this is a test question and you have no clue how to do it, you better put a dot on the y-axis for the y-intercept. In this particular case, it's 9, so I'll make it go through that point right there. And we'll label these points. This is 3, 0. This is 0, 9. Maybe label one other point, like this one right here was 5, 4. And that ought to be pretty good. Any questions? Okay. Domain. All real numbers, right? It's a polynomial. You can plug in anything you want there. What about the range? Okay, again, range is the y-axis. If we squish this onto the x-axis, the whole thing's covered. That's why the domain is negative infinity to infinity. But the range would start at 0 and go to infinity, and it would be included because it does actually come down here and touch at 0. Any questions there? Okay, the next part is, where is this increasing or decreasing? Now, some of you noticed that on the test, it asked you a question about what's this function doing on this interval. It said interval, but it looked like a point. And that can be a little bit confusing. Remember, increasing and decreasing is only defined on an interval. So, where is this increasing? Okay, Justin, what was it again? 3. It is 3 to infinity because it's increasing along here. But remember, if we say where is something happen, we want the x-coordinate. From an x-coordinate of 3 forward, so we're going to go 3 to infinity. And where is it decreasing then? Negative infinity to 3. Okay, are there any questions about that? Now, yeah. I think we talked about this before. I could easily put 3 in square brackets. It doesn't matter. I would take either there. Some people like the parentheses better, the round brackets saying it's not included, because really what's happening right there is it stopped for just a second. Down, 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 down. Stopped for just an instant, and then it heads up. So it doesn't matter. You could do either one you want. Okay. And there's not really a conflict because 3 is a point. It's not an interval. We're not overlapping these in any way. Okay. Good question. I'll take either. Good? Okay. Again, that's not the only way to do these problems. So let's take a look at another way. On this one, we're going to go about this. We're just going to kind of think through because, again, the idea here is that you understand these really well and can think your way through these. So I've got to do all the same stuff. The instructions are exactly the same. Is there something that I could spot from the get-go that would be helpful? What did I say the easiest piece of information was to spot up here? The y-intercept. What's the y-intercept? The y-intercept is 1. So I'm going to take this and I'm going to put a point at 1. Sorry. I'm going to blame it on my computer. Okay. Let's say we want to find the y-intercepts. Or sorry, the x-intercepts. How do you find the x-intercepts on this right here? Plug in 0 for y, and then we'd solve this, right? So this would be negative 2x squared plus x plus 1. We could complete the square. Could if you wanted. I mean, if we were going to complete the square, we could just put it in vertex form and then go from there. Any other ideas? We could try and factor it. Let's see if this factors. Now, I don't like the negative in front there. So I'm going to multiply everything by a negative, and I get this. 2x squared minus x minus 1. Hold on. Now, if you know how to factor it, that's great. If you're really good at factoring, that's awesome. What if you didn't know how to factor this? Or what if it didn't factor? Then you'd use the quadratic formula, right? Question? Yes, yeah, you'd have to. Yeah, and the reason it was okay to multiply both sides by a negative when we didn't do stuff like that up here on the first page is, this is just a number. We can mess with it all we want as long as we're doing legal algebraic moves. Okay? I said legal algebraic moves. Yeah, absolutely, and get the answer wrong. Okay, does this factor? It does. Got a 1 here and a 1 here. Which one needs to be negative, the first one or the second one? The second. The second one has to be negative. Sorry. Second one has to be negative. Let's just double check that. I did this by guess and check. These are small enough numbers. I mean, the only way to make a 1 is with 1s. Okay? And then the question is which one's positive, which one's negative. That makes a 2x squared. That makes a minus 1. This is a 1x and a minus 2x. So that does give us negative x in the middle there. Now, my question for you is, remember we're trying to find x-intercepts. What's the x-intercept that comes from this one? This would be 1. What's the one that comes from this one? Negative 1/2. Now let's take a look at that. So we've got an x-intercept at 1 and an x-intercept at negative 1/2. That's what it looks like, right? Okay. If it goes through this point and then this point over here, wouldn't it have to look something like this? It would, wouldn't it? Okay. Let's see. Any ideas now? It does open down because of that. Are we comfortable just doing this? Okay. If you were going to convince somebody you knew what you were doing, you'd have to do what else to this? Okay, we would have to find the vertex. I'm thinking of label this thing right here, negative 1/2, 0, and then this is 0, 1. I have to find this point right here. So how do I find that point? You can put it in vertex form. That would be one way to do it. And there's no doubt that we could do it if we put it in vertex form. You'll notice that if I were to do this by putting it in vertex form, though, whoops, let me do an f of x. This would be a negative 2, x squared. This would be a minus 1/2, correct? And this is going to be a plus 1. What makes this tough? Fraction. Half of a half is negative 1/4, right? Square that, that's 1/16. Multiply here, that's minus 1/8. And then I'd have to add 1/8. You with me there? Zach, did you make that mistake where you didn't do the opposite thing?
Sort of. I
Okay.
did 1/8 instead. I timed it. Yeah.
Okay. Any questions about that? Okay. What are we really after here? We're trying to find the vertex, right? So if we put this in vertex form, here's what we have. Negative 2. We know it opens down and has been vertically stretched. X minus 1/4. That's why we put this one right here, and I forgot to put my little dotted line around that. So that's minus 1/4. And then plus, what do these add up to? 9/8. A little bit, an eighth more than 1, right? Any questions? So where is this vertex? 9/8 is the y coordinate. 1/4. Okay. Now that is ugly. Very ugly. Now some of you might be saying, well, wasn't there a formula that we learned in 1010 that said here are the coordinates of the vertex? What is it? Negative b over 2a, opposite of b over 2a. So let's take a look here. If I said opposite of b over 2a on this particular problem, opposite of b is negative 1. 2 times a, that's negative 2. So this is going to be negative 1 over negative 4. What's my answer? 1/4. There it is right there. Now here's the problem. That's the x coordinate of the vertex. How do you find the y coordinate of the vertex? Okay, the formula looked like this. It was negative b over 2a, comma, f of negative b over 2a. And as ugly as this is right here, it just means plug it in. That's really all it means. But look at this ugly number we have to plug in. I have to plug it in here, and then add all of those up. So, is completing the square to put it in vertex form that bad of an idea on this particular one? No, it's actually a pretty good idea because look, I mean, even though there's some arithmetic to do here with fractions, it's the same process we went through here and on the front page. It's a pretty familiar thing, and it ought to be familiar. And please don't discount completing the square because it will come up again, and if you don't know how to do it, chapter 7 is going to be a nightmare. Okay? So please practice it. Don't get reliant on, oh, I know negative b over 2a, and then I just plug it in. That's going to take care of everything. Okay? Please don't just rely on that. It goes back to that. It's always good to have more than one way to do something. Okay, are there any questions there? Let's see. It does open down. We have its vertex. Axis of symmetry. X equals 1/4. X and Y intercepts, got those. Domain, let me go ahead and write that down. Domain is all reals, negative infinity to infinity. You write the range. Where does the range start? Starts at negative infinity. Again, we always go from smallest to greatest in interval notation. How high does it get? 9/8. Didn't do anything near this complicated in 1010, did we? Okay. And where is it increasing and where is it decreasing? Zach? No, go ahead. Oh, yes. Thank you. Thank you. Yep. Too much talking, not enough paying attention. Okay. What's increasing? Ooh, careful. Remember, we're saying where, so it's got to be an x coordinate. 1/4. Very good. Okay. And 1/4 to infinity. Okay, are there any questions there? Okay, now, just, we're going to, so I've got, what have I got here? Got a couple more examples. On the next page, if you want to pull this up on the website, it's the steps for completing the square. Notice that they've got the formula negative b over 2a, all that sort of stuff. So complete the square to put it in this form and graph it using transformations. On this one right here, use those formulas, and then you can use the discriminant to tell whether it opens or whether we have 1 or 2 or 0 x-intercepts. Look at all those steps. 2 steps here, pretty familiar. I do just want to say this. I mentioned a minute ago, please don't just, I know how to do it one way, don't teach me anything else. That's a really bad way to think, especially in math. This, in 1050, the reason this is required of most majors is because if you can get through stuff like this changes the way your brain thinks. This is a lot of stuff to keep track of, a lot of different methods to use on the same type of problem. If you can get your brain to kind of stretch and wrap your mind around how this works, you're going to be better thinkers in general, not just in math, not just in science, but better at a lot of other things as well, okay? So please give it the effort that it requires. Okay, now, any questions so far? Okay, let's take a look at the next one and let's use our head on this one. Exact same instructions. Take a good look at this. What can you tell me about it? Okay, well, there is a y-intercept. It's 0, okay? Something else?
It's actually really easy to find out the x-intercept.
Why is that, McKay?
Because all you have to do is take out an x from both, set them equal to 0. So one x-intercept equals 0, and the other one just equals 1/4.
There we go. Okay, easy to factor. We have it in factored form. Now, I really want you to pay attention to this because this builds on some stuff that was mentioned but not stressed a great deal in 1010. This is an x-intercept right here. 0, 0. That's another x-intercept. 4, 0. this parabola opens up. This parabola opens up. Now think for just a second. This is a parabola. Parabolas are really nice. They're symmetric and they've got all these nice behaviors and everything. One side looks like the other side. If this is a parabola that opens up, can you visualize what it would have to look like? And the important part is, don't say anything out loud. Can you tell me the x-coordinate of the vertex? Okay, that would be the opposite of out loud, in case you were wondering. What is it, Justin? It's 2. It's got to be 2. Because if these two are symmetric about a line, the axis of symmetry, that axis of symmetry has to be right here. It has to be at x equals 2. Now working backwards, if you know the axis of symmetry, you know the x-coordinate of the vertex. And if you know the x-coordinate of the vertex, we can just plug it in. 4 here, minus 8 here. What's the y-coordinate of the vertex? -4. So this is 2 comma -4. This is 4 comma 0. This is 0 comma 0. And the graph looks like this. Now, if I had this information right here, would anybody doubt I know what I'm doing when I'm dealing with this particular parabola? Nope. Now, let's finish off the question. We've got it opening up. We've got the x-intercepts. Okay. We found the y-intercept. I guess I changed the instructions there. Domain and range. Domain for a parabola, unless something really weird happens or we're given some restriction, it's going to be -infinity to infinity. Range. Where do we start getting answers in the y direction? -4, include that, go to infinity. And it's increasing and decreasing. Remember, x-coordinates. 2 to infinity is where it's increasing. -infinity to 2 is where it's decreasing. Okay, are there any questions? Sure? Okay, let's flip back to example 1. Take a quick look at that. Okay, what's unique about these x-intercepts here as opposed to the other ones we found? Okay, let's find out. So 2, 8, and 5. So I'll do y equals 2x squared, 8x, 5, right? Does it factor? Nope. No, we just want to flat factor that polynomial. If you multiply the 2 and 5 together, you get 10. Are there numbers that multiply to be 10 that combine to be 8? Nope. Doesn't factor. Quadratic formula. So this is going to be x equals, oh, please don't give out on me now. Opposite of b, so that's going to be -8. Yep. Yeah. Mm-hmm. Yep. And it would be plus or minus. Okay, I'll finish this on the board. So let's see. Plus 8, so that's going to be minus times c. Don't do this. Don't do that in your head. It's going to do and c is 5. And all over space. So there. So for yourself, how I do it, you take right the radicals to the right c. It might be adding or subtracting. I'm going to be subtracting. 4 times 2 is 8. Times 5 is 40. Here's what I get. 8 plus 3 is 24 over 4. And we do that 4. 2 times 2 times 3, right? Pair. So this is 8 plus 3 minus 2 radix 4. What else? out of 2, you can cancel it to everyone in terms of this. If 4 plus or minus radical 6 all over 2, you know, this is in 10. I'm going to write it this way. I'm going to write it as negative 4 over 2 plus or minus radical 6 over 2. What is this? Get 2 plus or minus radical 6 over 2. What is negative 2 on the problem? That's the x coordinate of the vertex. This is I give you this here. That is the x coordinate of the vertex. It's not mystery. It comes from the quadratic formula. Oh, if you look at that graph, and we'll get together. Very vexing. How many PU you use right now? That's fine. I only have run. I need to run. That'll go. Sorry. I'll have to have it again. We played on the board. So if that one was this distance is there. We're going to have to get this one. And we're going to try to get to that. The x-intercepts are equals about the sort of axis of the side. Now, on the back side, question. Or could you take a look at on page 298, 299? Let's see. Example 5. I have a problem. Squared plus bc. It goes as a vertex. I think it's 3, 5. This is on that. So it goes through 0, 0, couple. Right here. If you know that, use this one. It's going to be right. Yeah, this is going to be x plus 3 quantity squared. And this is going to be plus. This piece of information. I just need a is. So if I put a 0, what do I have? So it would be negative a. What am I looking for? I'm looking at 3 and after that. Or that plus. This is going to be plugging in 0 plus. So this is going to be. This is going to be 9 5. That over here is 5. So I have minus 9 equals. So we got a 9a. So what's that? Okay. 8 and 1. I can take this. I can put it right here. Set this in. So up to there.
First off, minus 3.
which gives 6x plus 9. Negative 6 squared is x minus 9. So you get squared minus 6 minus 4. There's the answer. Have a problem? These are the best. So this form, we use x form. And all dollars should be. Then we have the base. Solve for. So I have vertex form to be through terms right each other. And yeah, but it's a little bit hard. So you could put negative. Negative b over 2a, and you'd have estimations to solve. Oh yeah, plenty of solutions. Okay, maybe I got this test for you.